Hello, my name is Guillaume. I'm going to present my method developed for HPLC analysis. So we start and we go to step zero. Step zero will be actually understanding the physical chemical properties of our analyte. For example, you can look factors such as molecular weight, pKa, log P, and so forth. So the other thing that you have to do, you have to make an initial choice of both the organic modifier and the stationary phase. So now we're going to look at the stationary phase, which is basically choosing the column. So there are different columns and they all behave in different ways. So you can see from here we have a C18 column, and here we have ultra IC18. They all behave different. You see here is the hydrophobic is actually around 7, where he is actually 10. So they behave differently. So in our case, a C18 column was chosen initially, and you have to make a choice of the organic modifier as well. In our case here, we chose a CN at the start, and the solvent is actually used to change the hydrophobicity of the mobile phase. So here we have two approaches, path A and path B. Path A starts with a gradient, a scouting gradient. Path B actually is another gradient. That's not with 100% B. Let's start with path B. So we start with 100% B, and the mobile phase was very hydrophobic, and then this is what we got. So this chromatograph is very, like, sort of everything stuck together. You can see potato looking, and this is our checkbox. So we need to get a resolution more than 1.5. If you say it is actually less than 1.5, and K is not less than 115, and also we need to have adequate pressure, which we actually achieved, and the sensitivity is not that great. So we have to move to the second step. And second step, we actually deal with the change to change K, so that we can have K in the acceptable range. After this was done by changing percentage B, reducing percentage B, realize that each decrease 10% will increase K by a fold of 2 to 3 factors. So this is a chromatograph that option. We have 70% B. You see, we have only 5 peaks. So whereas we need to get 7 at least. And here this is chromatograph when we were using 50% B. And if you look at the checkbox, we were able to achieve a K less than 15, but the resolution is actually not that great because it's still less than 1.5, and pressure is good. So the resolution is now actually between 1.2 or 1.49, still less than this. So the next thing that we do, we move to step 3, which is basically we change the selectivity. And there are 4 ways that you can do to change selectivity. Approach 1, you can change the temperature. So changing the temperature can lead to change selectivity. And this is a chromatograph that we obtained when we changed the temperature from 4 ambient to 40. You can see that these peaks are different, and the order of elution is different. That means the material has been altered or changed. And you can also change mobile phase pH. So this is what we obtained with a pH of 7, and this is a pH of 3. So you can see that order of peaks are different. You can also change solvent type, so either from methanol to ACN, because we had ACN initially, so we changed methanol. So to change that, you have to use a nomogram. So for example, 50% of ACN is actually 50% methanol, but we use 55 methanol so that the retention time is the same. So this is what obtained 65 methanol and 50. You see that is different. What I'm are different. So if you look at 50% and 60%, 60%, 65% methyl and 50% ACN. So for ACN, ketoprofen and naproxen are stuck together, and when change to methanol, we get a different protein. Naproxen student are overlapping, so we use the mix to separate all of them. That are when we use the mix, we're able to separate all of them. But the problem that we had again is that the resolution was still not equal to 1.5, but it was close to it. So and it was close to it. So it was close to this value. So this is the result of obtained using the mix. You can see that the K is still in the acceptable range of 8.22. So we, the resolution is actually close to 1.5. So we move to step 4. Step 4 actually deals with changes efficiency, and their efficiency is actually a mechanical parameter dependent. So it can only be changed by mechanical parameters, changing of column length here. So when you change column length, that should reduce runtime, but it does not actually improve resolution. So change of flow rate, here the small flow rate actually is better, and change of column diameter. If you change the column diameter, small diameter is better than bigger diameter, and particle size. If you have small particle size, improve separation, ultimately improving resolution. And this is the chromatograph that we obtained after changing a few efficiency parameters. So we can see that the resolution is more than 1.5 K. It's within the specified range. Which is good. It's good. So now what we do need to do, go to validation method, which we're gonna talk about later in our presentation. So now let's go to part A. Part A starts with the scouting gradients. Scouting gradient will actually help us decide whether isocratic method is possible or gradient method is possible. So for isocratic method to be possible, these have to be split, these have to be met. So changing TG have to be less than 0.25 times TG, which is the gradient time. So if that one is not met, so gradient method is the only possible way. So let's go to our checkbox. So our checkbox will see if this is met. If this condition is met, we move to isocratic analysis. So isocratic analysis, we start with we can actually determine the mobile phase composition by following this instruction here. And if we do it, we go to our checkbox and see if these conditions are met. If these conditions are met, we go to method validation. However, if they are not met, what we do, we ask ourselves what's wrong. If K is not in the specified limit, then we change K by decreasing percentage B. Or if the peak are nowhere separate, we change selectivity. And if K is good, back pressure is good, but resolution is still less than 1.5 but close to it, we then change efficiency. So let's now move to when gradient method is the only possible way. We can move and do gradient analysis. Our checkbox again, this is what we're gonna look and see if they are specified, if they are met. If these conditions are not met, we can't do anything. So if they are not met, we look for ways to optimize K, and this is K from the gradient analysis, and the gradient analysis is calculated by this equation, and we can change these parameters to optimize it. So change flow rate, having small flow rate actually is good because flow rate it's going to increase TG and ultimately increasing K. You can also change column length. So having a shorter column length is better than having a bigger column length. You can also change the organic range I can also change the gradient stiffness. So the gradient stiffness actually will determine if TV is big or small. And this is a chromatograph that will after optimizing K. You can see that from this study, you can see that K is 4.32. So the blood pressure, is good, and sensitivity is good as well. So now move to method validation. So what is method validation? Method validation is actually made of two parts. One is quantification of the compound. You have to quantify the compound by using calibration curve and peak area to determine various factors such as response factor, amount of unemployment sample. We can use these steps to know how much is in the sample or peak area here to determine response factor and so forth. Second point of the analytical method validation is analytical procedure, whereby you measure accuracy, and accuracy is actually basically how close the value is to the true value, and it's actually measured in average recovery, and you have to be between 98 to 102. And also you can measure precision. Precision actually have three things: repeatability, intermediate precision, and reusability. And for intermediate precision, there's some information about it, but the acceptance criteria have to be equal to 2% for individual basis, and for reusability, it have to be equal to 2% as well for individual basis, and for repeatability, you have also to be less than or equal to 2% to RSD. And robustness actually look at how the method will not be affected by any changing parameter. So the difference have to be 20% from the original conditions, otherwise it's not, you won't pass this test. And finally, not least, you have to look at the system stability. Is this suitable? And you have to be, for HPLC, have to be specific. For example, you have to be able to distinguish one peak to another, so the resolution have to be good. Limit of detection, you look at how much can you detect in the sample, how much can be detected in the sample, and quantitated. And the acceptance criteria will be S2N ratio must be greater than or equal to 3. And finally, limit of quantitation, you have to, is actually how much the smallest amount that can be analyzed and detected, and the S2N ratio have to be greater than 10, and you have RSD, which is less or equal to 20. And range, this has this to accept criteria, and also we have linearity, and this is the accepted criteria as well. This is more information about linearity. So after you see all the criteria set by method validation are met, if they are not met, we then go to devising new methods, because the first one failed. These are some things that we can do to come up with a new method. And if yes, then we finish. And thank you for listening. This was my presentation for the method of HPLC.